Hey guys, welcome back to another Leetcode video. Today we're going to be looking at Leetcode 100, same tree. We're given the roots of two binary trees P and Q, and we need to write a function to check if they are the same or not. And we're told that two binary trees are considered the same if they are structurally identical and the nodes have the same value. So we can see we've got P here and Q here, and they both are basically the exact same tree. In this example, the trees aren't the same, they're symmetrical, but they're not the same, so we return false. And in this example, they also aren't the same, so we return false. And we're given some constraints as well. We're told the number of nodes in both trees goes up to 100, so we can use the first search approach for this problem. And we can basically do this recursively. So let's hop straight into the code. We wanna kind of look at our base case, and normally, let's say we had just a root, we'd say if not root, return true, because that's kind of like the default depth first search base case for a lot of these problems. But since we've got two trees, now we're going to say if not P and not Q, then we return true. So this is our first base case. We want a second base case. We want to say if not P or not Q. So maybe P is null and Q is not, Q is null and P is not. In this case, we know they can't be the same because the values aren't the same. So we return false. And then we want to compare the values themselves. So we want to return does p dot value equal q dot value, and we also want to say, well, depth first search. So if p dot left is equal to q dot left and p dot right, is that equal to q dot right? So that's our depth first search function. Oh wait, well, let's put this into a depth first search function actually. Let's say P and Q. Let's paste our code in here. It just makes this a tad bit easier. And then we can return depth first search on P and Q. So let's run our code. Expect an indented block after if statement. Okay, let's indent that. Submit our code, make sure our problem actually does work, and it does. We pass all 67 test cases with quite an optimal solution. So that's the problem. That's the solution there. It's quite simple. In terms of time complexity, we're looking at an O of P plus Q, so P and Q being the trees. So O of P and Q will be the time complexity. So I hope this video was helpful, guys, and I'll catch you very soon.